Hello and welcome. In this lesson, we will explore one of the most famous theorems in geometry, the Pythagorean theorem, or if you say it in Greek, Pythagoras theorem. The Pythagorean theorem describes the relationship that exists between the side lengths of a right angle triangle. Recall that in a right angle triangle, one of the angles will measure 90 degrees. So this is what we call the right angle. Now, the 90-degree angle would be the largest angle in a triangle, and the side that is opposite to it as a result will be the longest side in a triangle. And that has a special name, which you probably remember from elementary school. We call it hypotenuse. I like to call it hippopotamus because it reminds me that it's the longest side in the triangle. And the other two sides, we're just going to call them the other two sides of the right angle triangle. Now, in order to discover the relationship between the three side lengths in a right angle triangle, we are going to conduct this very simple investigation. So, how are we going to do this? So, I have put a grid in here, and as you can see here, there are so many little squares. Each square measures 1 centimeter exactly. So if you are printing this out at home and trying to follow the video by actively taking notes, then please know that this will be 1 unit long. And then what we are going to do is draw 3 different triangles of different sizes. So we are going to get started with the first triangle that has the side lengths 3, 4, and 5. When you think about it, 5 is the longest side, and that should make us think that, 5 must be the hypotenuse, because hypotenuse is always the longest side in a triangle, right angle triangle, obviously. So the sides 3 and 4 will be the normal or the other two sides of the triangle. So here we go. I'm going to get started by drawing one side 4 units, one side 3 units, and then I will connect them. If you have a ruler at home, which would help a lot, what you want to do is use the ruler to measure the third side. I'm going to label the side A, which is 3. Here is the side B, which is 4. Now, if you use the ruler, this time I've measured this for you, so it's ready. So the third side, or the hypotenuse, will be 5 centimeters. Now, let's continue drawing triangles, so the rest of the triangles, so that we can have all the triangles on the grid first and all the measurements in here, and then we will focus on the calculations. So the next triangle you want to draw is the one that has the side lengths 6, 8, and then we'll have to use a ruler to measure the side C. So I'm going to check and see how many squares I have in here. 1, 2, 3, 4, 5, 7, 8. So I don't think that I want to draw the triangle, the side length of 8 units here. So I'm going to go 6 units around this area. Here. So let's draw a nice straight angle here. And then 2, 4, 6, 8. All right, and now this will be the right angle. And now I'm about to draw the hippopotamus. Call it whatever you want. Oops, I want this to be a bit straighter. Oh, sorry. Here we go. So here we go. We have the hypotenuse. You can use a ruler to measure the length of it. And another thing we have the other measurements we have in here are 6 and 8 centimeters. Okay, so if you use a ruler, which it's probably the better way to approach this investigation, then you will find out that the side length of the hypotenuse will be 10 units or 10 centimeters. So we are going to say that while A is 6 and B is 8, C equals 10 centimeters. So I'm going to write this down here. And now we are going to draw the triangle with sides 5 and 12. So I'm going to start with drawing a side that is 12 units long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and then the other side will be 5 units. So 1, 2, 3, 4, 5. Oops, I needed a straight line here. 2, 3, 4, 5. And here goes my right angle. And now I'm going to connect these points. Perfect. And we are going to say that this will be the longest side of the triangle, or the hypotenuse. Hypotenuse, obviously. Let's learn the terms right. Okay, so this would be the side that is 12 units long. We call this B. And this one is the side 5 units long. And we call this the side A. And now we are going to use a ruler to measure the length of the hypotenuse. So if you were to measure the length of the hypotenuse, then you will find out, just by using a ruler, that the hypotenuse will measure exactly 13 units or centimeters. So I'm going to write this down here. And now I'm going to start with doing some calculations here to fill the chart. So we're going to have to find the values of A squared, and then B squared, and then add A squared plus B squared, so these two numbers. And then we have to square the last number, C. So A squared is 3 squared or 9. B squared is 4 squared or 16. So A squared plus B squared, that must be 9 plus 16 or 25. C squared is, look at C here, 5 squared. So that's 25. Now continue with the next triangle. We have A squared, A is 6. So A squared is 6 squared or 36. And then B squared, so B is 8, so 8 squared equals 64. And then A squared plus B squared will be 36 plus 64. So 36 plus 64 equals 100. What a nice number. And the last number, C, is 10. And C squared will be 10 squared or 100. And let's do the last calculations. So we have A squared or 5 squared equals 25. B squared will be the 12 squared or 144. We're doing the same thing, right? So A squared means 5 squared. B squared means 12 squared. And now we are finding the sum A squared plus B squared, which is 144 plus 25. Or let's put it this way, 25 plus 144, 169. And now, last but not least, we have C squared, which is 13 squared. Or use the calculator to find the value of it, 169. So you've probably already noticed that A squared plus B squared and C squared for the blue triangle was the same. But that might have been a coincidence, who knows? But then when you checked with the second triangle, then you find out that, again, we see the same pattern. So A squared plus B squared equals the hypotenuse squared. And the same thing happened with the last triangle. So now we have a more consolidated idea about the relationship that exists between the side lengths in the triangle. And we're going to write that c squared equals a squared plus b squared. And it's a very famous formula, and I'm sure many of you have heard of it. Many of you already know how to use it very well. But I'll tell you one thing before we move on. Very often, whenever we're asked to explain what Pythagorean theorem is about, people say c squared equals a squared plus b squared. And that is great. However, sometimes, and when I say sometimes, it happens to everyone to make this mistake at least once, people forget that the names don't always have to be C, A, and B. And the hypotenuse isn't always C, right? So in order to really understand the Pythagorean theorem and use it accordingly and properly, what I suggest that we do is write hypotenuse squared equals, and you can write a squared plus b squared, x squared plus y squared. It doesn't really matter. It depends on the names that you've given to the other sides. But please make sure that hypotenuse will always be sitting in one of the sides of the formula all by itself. So now let's take a look at some applications of Pythagorean theorem. So we're going to learn things slowly, okay? And I want you to remember first, again, same thing. Pythagorean theorem can only work in right angle triangles. So same thing that we've mentioned before. And when we use the Pythagorean theorem on one of the sides of the formula, we have to have only the hypotenuse, okay, to the power of 2. So the formula must be hypotenuse squared equals, and then you have the other sides. And remember that Pythagorean theorem cannot be used in triangles that do not contain a right angle. Why? If there is no right angle, there won't be any hypotenuse, right? And Pythagorean theorem is about that relationship that hypotenuse has with the other two sides. So let's move on to example 1. So in this example, we're asked to label the hypotenuse and then write the Pythagorean theorem. So what I like to do first is locate the right angle. Opposite the right angle, it's always the hypotenuse. So we're going to say that here goes the hypotenuse here for the first triangle. I want to make it a different color because it kind of stands out a little bit more and it's clearer. Okay, and here goes the second one. So here's the right angle, here's the hypotenuse. Here's the right angle, here is the hypotenuse. It is very important that we get used to the idea of not calling the hypotenuse C all the time, right? So the answer is not C all the time. Here, right angle, hypotenuse. Same thing here in the last example. So right angle, hypotenuse. So it doesn't matter. The orientation of the triangle shouldn't actually confuse us as of where the hypotenuse is located. And now you have a name for each side, as you can see here. And when we name the side lengths, we always use lowercase letters. And when we name or label the angles, we always use uppercase letters for angles, okay? And again, there is a relationship between the types of letters or the letters that we're using for angles and the sides opposite to them. For example, opposite angle B, we mark the side lowercase with a lowercase b. Opposite angle C, we mark the side length with a lowercase c, and so on and so forth. So I hope we're now ready to write the formula. So we always start with the hypotenuse. Here is the hypotenuse. Hypotenuse is b, so I write b squared equals. The hypotenuse has to be by itself. And I'm going to do this same thing in every triangle. So here is the hypotenuse. So the formula, hypotenuse is denoted by letter h. So the formula starts with h squared. Here is the hypotenuse. We have called hypotenuse n, so n squared equals c. So I make sure the hypotenuse is sitting all by itself. And then next, hypotenuse, j, so j squared equals. Next, hypotenuse is h, so h squared equals. And then I write the sum of the squares of the other two sides, which are a squared plus c squared. And I did this on purpose, actually, just to show that the Pythagorean theorem, right, is not carved on stone to be c squared equals a squared plus b squared. It will be this formula if the hypotenuse is named with the letter c, okay? But you see, in this case, we have hypotenuse b, so b squared has to stay here. I can't emphasize this enough because I see that we tend to make mistakes very often with this. So the next one, we have g squared plus I squared. And I encourage you to continue completing this on your own. M squared plus O squared. So that's letter O in case it's confusing to you. It looks like a zero, that's why. And then L squared plus K squared. And this is G squared plus I squared. So the purpose of this exercise is to show us the different faces that the Pythagorean theorem can, can wear sometimes. All right, so we're moving on to example 2, and now we are going to do some calculations. So in the first example, we have triangle ABC. And I always try to focus first on the right angle, so the right angle B, and I want to label the hypotenuse right away. And I want to examine what I have. So I have this side, I have this side. It is right angles, which means I can use Pythagorean theorem, and I need to find the hypotenuse. So I am going to write the Pythagorean theorem. B squared equals C squared plus A squared. Remember, hypotenuse has to sit by itself. So B squared equals 4 squared plus 3 squared. That's 16 plus 9, or 25, which will make B equal to square root of 25, or simply 5 centimeters. I usually like to box up the answers, if you've noticed. It kind of makes them stand out, and it's like a sort of a short statement. Moving on to the next example. Obviously, you should try this on your own if you feel confident enough. If not, just continue on by listening to the explanations. This time, again, we have a right angle triangle, and it is named DEF. Now, here is the right angle. I will label the hypotenuse. And now I'm going to write the formula. So hypotenuse is denoted by letter E, which means that E is going to sit all by itself on the left side. So E squared equals F squared plus D squared. And now I will substitute. So the length of E is 10. F is unknown, and D is 6. So there are different approaches you can use to solve this very simple equation. So I like to find the number squared first. 100 equals F squared plus 36. And then since we're solving for F, we're going to leave F by itself, and we'll bring 36 over. So now I have 64 equals F squared. And that means that f equals the square root of 64, or 8 meters. And here we go, 8 meters. We're done. Moving on to the next example. This time, we are not given the names of the sides, so this is a little bit more challenging. Nothing that you can't do, all right? But we're not given the side lengths or the names of them. But obviously, you can see this is a right angle triangle. And when I read the problem, it says we're given two sides, A and B. So one of the sides will be A, the other will be B, all right? It seems that A is shorter, so I'm going to call this one A and this one here B. And we have to find the unknown side C, which is the hypotenuse. So we already know this is the hypotenuse. And what we are going to do is write out the Pythagorean Theorem. So hypotenuse will sit on the one side of the equation, so C, which will equal A squared plus B squared. So C squared equals 8 squared plus 15 squared. Obviously, you can use the calculators. However, some square numbers you can do in your head. So it's multiplication table, right? And we have C squared equal to 289. So that makes C equal to square root of 289, or 17. Voila, 17 centimeters for the side length C. And you're done. Now, we're going to move on to the next example, which is the last example for our lesson today. And obviously, this example is a little bit more challenging. It has an extra step. Nothing, again, that you cannot do. All right, so let's work on it together now. If you find that you are figuring out the next step without me explaining, again, stop the video and try to do this on your own. I first like to read the problem. Every problem has a story. And when I read the problem, I kind of get an idea what it is about. And most of the time, I don't understand everything right away. But I know that that's normal. I don't have to learn everything right away as well. So here we go. Here we have given the sides as indicated. Okay, so we have two sides given. Oh, we also have a right angle. We have to determine the area of this triangle. And we are given the formula for the area of the triangle, which is base times height divided by 2. Now remember that when we look at any triangle, and I'm just going to draw a random triangle in here. So the base can be any of the three sides of the triangle, right? Whichever you pick. The height of the triangle will be determined based on the base that you have chosen. So if I chose this base in here, then the height will be perpendicular to this base, okay? Or the perpendicular to this base, goodness. So do you see in this triangle, right? Do you see two sides that you can call base and height, right? And we all look at things differently, or we see things differently. And you're probably thinking, oh, this is the base. Perpendicular to this will be this side, which is the height. So I can call this the height. Or maybe some of you are thinking, maybe this is the base. And this is perpendicular to it, and I can call this the height. Now, let me tell you one thing. It doesn't matter which way we measure the triangle. It is the same triangle, so it will have the same answer, the same size, okay? So what I have decided to do is call this side in here the height. Okay, and I am going to give it the name H. And I am going to call this side in here the base. And I am going to give this the name B. And now I'm thinking, since I'm asked to find the area of the triangle, it's enough that I substituted the base and the height into the formula. So I will substitute the base is 7. It seems that I don't have the height, so I'll leave it as H for now. And then divide by 2. And now I'm thinking, my goal is to find this, but I wish I had this. So we always look for what do I wish to have. So whenever we get stuck and we don't have an unknown, we have to think, okay, so I don't have it. That's okay. How can I find it? So that's what we are going to do now. So we are in search of the length H. So we're going to take another look at this triangle now. And we're going to think, okay, so in this triangle we have 2 side lengths, but we don't have the third one. It's a right angle triangle. Is there a way for me to find H based on what I've learned? Obviously, Pythagorean Theorem is the first one that comes to our minds whenever we are dealing with right angle triangles. So we're going to say, wait a second. This one here is opposite the angle 90. So this must be the hypotenuse. Now, I'm going to give the hypotenuse a name. So I will call it, I don't know, we can call it A. It doesn't really matter. And then we're going to say, in this triangle, hypotenuse A squared will sit by itself in one side, and then it will equal B squared plus H squared. I'm so lucky I have the hypotenuse, so I will substitute it. B is 7. And as you can see, I only have one unknown here, H. 25 squared, use the calculator, that gives 625. 7 squared gives 49, and then plus H squared. And then 625 minus 49 equals H squared. And that will make the length H equal to 625 minus 49 is, I would say about 576. 576. And therefore, we're going to say then the height must be the square root of 576. Use the calculator to find the square root of 576. That's 24 meters. So now we're going to say, let's get back to the beginning of our problem. And we're going to say, okay, area formula, we have great news for you. Now we know what the height is, and we're ready to substitute it into the formula. And 7 times 24 divided by 2 is like 7 times 12 actually. And 7 times 12, because just use a calculator, and the calculations are actually very straightforward. So I was thinking 24 over 2, which is 12, right? And trying to do this in my head. It's a habit. So that's 84. So 84, and we have one last thing missing here. Okay, I want you to think about it. We're finding the area, and the unit measurement for the area would be whatever unit we're using squared, because we're measuring multiplying meters by meters. And voila, this is the area of the triangle. I hope that this lesson was helpful in your reviewing or learning about the Pythagorean theorem, whichever the case was the case in this for any one of you. And I hope that everything made sense. And bye for now. Thank you for listening.